Okay, it says it's preparing the live stream. Okay, it says it's preparing the live stream. Okay, and we are live. So the live stream has a bit of a delay, which is always a little weird, but I think it's okay. Okay, and we are live. So the live stream has a bit of a delay, which is always a little weird, but I think we are live. So the live stream has a bit of a delay, which is always a little Okay, it's 8 o'clock here in the Netherlands, which means that it is time for our very first Baby and Child Research Center Science Slam. Hello and welcome, everybody. Thank you so much for joining us tonight, and we hope you have fun. My name is Lena Ackermann. I'm a postdoc at the Baby and Child Research Center, and I will be your host tonight. Voor de Nederlandstalige toeschouwers, de praatjes hebben alle ondertitels in het Nederlands. Ik ga nu een beetje iets in het Engels vertellen, maar voor de praatjes kun je dan daar ondertitels in het Nederlands zien. So people are still joining. I can see the numbers go up, which is very nice. I hope you're all comfy at home. You have your favorite beverage in hand, and I hope you're ready to take a dive into the world of developmental science. I'm excited, and I hope you are too. So, what is a science slam? Well, a science slam is a way for researchers to present their findings in short and engaging talks. We as researchers are all very used to presenting our research at conferences, to talk to other researchers, but what we hardly ever do is just talk about it as we would to a friend. And this is what a science slam is. Basically, the people who are here today want you to know more about all of the cool stuff that we do, and they have volunteered to present a very, very small part of the research that we do at the BRC, but I'm very glad that they are here. I am joined tonight by 4 amazing early career researchers who have put a lot of time and effort into their presentations and who are happy to share their research with you today. The talks are short, approximately 10 minutes per talk. We have some talks that are a little shorter, some talks that are a little longer, but all in all, it's just a quick highlight of people's research. And at the end, you can even vote for your favorite talk. I know that all of the 4 people who are speaking today have put so much work into their talks, but maybe there was one that you particularly enjoyed, one that showed you something that you didn't know before, where you had this light bulb moment where you were like, oh, wow, I didn't know that. Maybe there was one that made you laugh or one that made you think. Whatever your favorite talk was, at the end, there will be a link that we will show you where you can just let us know which talk you liked best. So before we start with the talks, I would like to tell you just a little bit about the Baby and Child Research Center here in Nijmegen. We are located in Nijmegen in the Netherlands. I've marked the approximate location on a map. Today was a very, very nice spring day here in Nijmegen. I myself went for a run, and I hope that wherever you are, you can also enjoy the weather despite the circumstances that we find ourselves in at the moment. At the Baby and Child Research Center, about 50 researchers study early development from before birth all the way to around 6 years of age. We are interested in very different aspects of child development, such as language acquisition, social and cognitive development, but also certain health outcomes of young children. The Baby and Child Research Center is actually made up of 4 different research groups that work together to investigate early development in young children. And researchers from the Radboud University, the Radboud University Medical Center, the Max Planck Institute for Psycholinguistics, and the Dundas Institute all come together at the BRC. So we are very committed to shedding light on questions of early development from a variety of perspectives. And today we have 4 slammers here that can only cover a very, very small part of what we do here, but we hope their talks make you enthusiastic about developmental science and make you want to know more about the cool research that we do here at the BRC. So let's dive right in with our first speaker, Julia.
Hello.
How are you doing tonight?
Great. Thank you.
Thank you so much for joining us. And you have a bit of a special connection to the BRC. Could you explain it briefly?
Yes, sure. So I'm actually not working in the Netherlands. I'm in Italy, in Milan, at the Milano Bicocca University, and I'm doing I am currently doing a collaboration with the Radboud University, actually with Marlene, that you can see here. And so I came to Nijmegen in September for a month to start a study there, and we're now working together remote. But yeah, I'm working on a study there.
Cool. So this is great. So this shows that the BRC is also very committed to international collaborations with researchers, not just in Europe, but also on other continents. And we are very happy to have you join us today. And we are looking forward to your presentation. Just one more question before we start with your presentation. What do you like best about working as a developmental scientist?
Well, first, I think it's really fun to work with children and babies because they're so cute and they're so fun. So it kind of makes it less serious because there's all this time in which you have to play with the children to make them comfortable. So it makes it really pleasant to have them, although it's very difficult and challenging too. And also, I think it's a great way to help children and practitioners, help parents and practitioners to learn about children's abilities and learn better how they work, how they learn, for example, and it's a great way to improve education, pedagogy. So have really a direct impact on society and try to make children develop in the best way possible. So, yeah.
Okay, so everybody, you can just sit back and enjoy Julia's talk.
Hello everyone, I'm Julia Mermier. Hello everyone, I'm Julia Mermier from the Bicocca Child and Baby Lab in Milan, Italy, as you can see behind me. And today I'm going to talk to you about my work on statistical learning in infants. So we know that infants can already do statistical learning from around 8 months of age. What? Really? Does that mean that infants can do statistics before they even talk or walk? They're geniuses? No. Sorry, let me explain you better. Statistical learning is actually the ability to track the regularities in the relative positions and order of the elements of a sequence. So for example, if I show babies a sequence of images of dolphins, cats, dogs, and birds, and that in this sequence the image of the cat is always followed by the image of the dog, as it is the case here. Babies will learn this order and use it to predict what's next. So, whenever they will see a cat, they will know that the dog will come next. And this is statistical learning. That is, when seeing the sequence of pictures, babies were able to notice that the cat was always followed by the dog, to learn it and to use it to predict what comes next. And babies use statistical learning in a lot of domains. For example, they use it to learn languages, which was actually the first domain in which statistical learning was studied in infants. So, when infants listen to a sequence of sounds, they actually analyze the probability of one sound to be followed by another. And if this probability is high, this combination of sounds is very likely to be a word. So for example, if I present infants with this sequence of sounds, sigh, tay, bull, air, row, ant, infants will be able to extract the word from this sequence, which in this case is the word table, because they heard so often the sound tay followed by the sound bull, so it is very likely that table is a word, which is the case. And infants also use statistical learning to learn about actions. So, for example, if I take a spoon full of food in my hand and I bring it close to my baby's face, I'm likely to bring it to my baby's mouth rather than my baby's eye. And because babies are so used to see the sequence of actions, spoonful of food goes in my mouth, as not in my eye, they learn this sequence and are even able to anticipate it, for example, by opening their mouth in advance. So now let me talk to you a bit about my study. So in my study, I wanted to look at whether 1-year-old infants can track the statistical regularities in sequences of emotional faces. Because babies constantly see social interactions around them where facial expressions of emotions succeed one another following specific patterns. And these patterns determine the meaning of the interaction. So our hypothesis was that the babies are actually able to detect these patterns of emotion. And to test that, we showed babies a sequence composed of 8 different emotions and used a method called familiarization. That is, we first familiarize babies to a sequence of emotions presented in a specific order organized by pair. So within a pair, for example, pair 1 here, the emotion number 1 was always followed by emotion number 2. So here, for example, amusement was always followed by disgust in 100% of the time. And same, exasperation always followed by fear. Sadness by surprise, anger by happiness. However, between the pairs, between, for example, pair 1 and 2, the order was random. And we showed this sequence several times, so babies had time to learn it. So then we showed them a new sequence in which some of the pairs were the same than during familiarization, for example, amusement and disgust, while some other pairs were new, that is, babies were not familiarized to them. For example, we showed sadness followed by anger. And we looked at babies' looking time to these familiarized versus new pairs to see if they were able to learn the order of presentation during the previous familiarization. If they were able to do so, we expected babies to look longer at new pairs to which they were not familiarized because they're new, they're more interesting to them, so it catches their attention longer. Inversely, we expected babies to look for shorter durations to pairs to which they were previously familiarized, because these are pairs of emotion they know, so they know that, for example, amusement is followed by disgust. Thus, it's less interesting to them, so they will look only for a short amount of time to these pairs. And so, this is thus, by comparing the amount of time babies looked to the familiarized versus the new pairs, that we can test whether babies learned the regularities in the sequence. So we still have a few babies to test, but from the intermediate results we have, it seems like babies are capable of doing statistical learning on emotional faces. I'll keep you updated once I have the final results. And so there is still a lot of research to do about statistical learning and about which domains infants use it. And so now, although we now understand that babies cannot solve statistic equations, they're not geniuses. But still, it's pretty impressive to see the complex strategies that they use to learn about the world, isn't it? Thank you for your attention.
Hi, everyone. So thank you so much for tuning in. And
Okay, thank you very much, Julia, for your presentation about the little baby geniuses that can track statistics and actually use it to learn about the world. So next up, we have Kloe. Hi, Kloe.
Hi, everyone.
Hi, how are you doing today?
I'm doing good. I really enjoyed the nice weather today, so I'm really chuffed for that.
That's great. So how long have you been at the BRC?
So I joined the BSc 1 year ago, so in October of 2019, which feels very crazy now to think about it. So yeah.
Yes, that's true. That was like a wild year to.
Yeah, it feels like a different life back then. Yeah.
Yeah, I totally get you. I myself only joined the BSc half a year ago, and it's a weird time to start a new job, and it's weird to think that everything was just so much different just a year ago. But anyway, what makes you excited about working in developmental science, Kloe?
I mean, it sounds cheesy, but I just love children, and I love how they can find interest and excitement in the smaller things of life. And I know it's super cheesy, but it's true. And they're also incredible fast learners, and also this is also connected why I love doing this kind of research. And from birth to age 3, we see the fastest rate of brain development in the entire human lifespan. And a baby is born with, if we think about it, with 100 billion neurons, nearly twice as many neurons as adults in a brain that's half the size. So a baby brain is more active than ours, and that's pretty cool. So that's why I'm so interested in working with young children.
Oh, wow, thank you. Yes, I mean, I totally agree that young children are really amazing learners, and it's impressive to see how they go from those helpless little newborns to those bubbly little personalities in just the first 3 years of life. And I hope you all enjoy Kloe's presentation on the emergence of autism in childhood, which will start in a second.
Hi everyone, so thank you so much for tuning in and joining my presentation on the emergence of autism in the childhood. So just to make sure that we're on the same page, I will first define autism and also give you a very brief overview on why we need autism research in the first place. So autism spectrum disorder, or ASD for short, is a neurodevelopmental disorder. So this means that it impacts the way the brain grows and functions. Symptoms occur in childhood, and currently diagnosis is made in the 3rd or 4th year of life, and this diagnosis is based on a list of different behaviors, and these behaviors can be divided into 2 main domains. First, we have the social domain, so children with ASD present difficulties in the social domain, in the social functioning, so the way they interact socially with others, and the other domain is defined by having restricted and repetitive behaviors. I also want to explain quickly what spectrum means, as I think it's still a buzzword in the field. In the past, the ASD spectrum has typically been visually represented as a linear progression, with not autistic on one end and very autistic on the other end. Now, the problem with this understanding of the spectrum is that it really oversimplifies this disorder. So a spectrum is not binary, it's not linear. And what's more important to understand is rather which areas of the brain are most affected in an individual in the spectrum. And so essentially the spectrum consists of many different traits or ways in which the brain processes information. Now, this means that we end up with a very broad spectrum of individuals that can meet clinical diagnoses, yet no individual is exactly like another. Now, this is very unusual in clinical medicine. For practically every other psychiatric condition that we know of, we're able to answer the question, what's this disorder a disorder of? So ADHD, for instance, is a disorder of attention. Alzheimer's is a disorder of memory. But when it comes to ASD, it's not as simple. There's no core to the diagnosis of ASD. Rather, like I mentioned, ASD is a constellation of symptoms. And this is due to a different number of different factors, different family genetics backgrounds, different environments. And this poses a great challenge for scientists, which are currently trying to make sense of this heterogeneity. And so, because of this heterogeneity, there's a great need for ASD research nowadays. So the next question I also want to provide you with is, what does neuroscience has to offer to ASD? So what role can neuroscience play into the current understanding of ASD? And spoiler alert, it's a lot. So we know, based on hundreds of studies done in ASD genetics, that the brain development is affected much earlier than the diagnosis is made, often before birth. So these are processes that are starting very, very early on in development, and therefore they affect the way the brain is wired. And so this actually has led to the coining of the term of ASD being developmental disconnection, which means that the way the brain is connected early in development is not quite normal. So connections are not forming a very typical pattern. So in this framework, I want to show this timeline. So as I mentioned before, we diagnose kids at around age 3 to 4, and then after this, they offer the intervention. But as I just discussed, we know that the brain development is affected very early on. And so we have a very important window of time in which we can, and also should, in my opinion, measure the emergence of these early differences in the brain. And why is this important? Well, if we can define these early differences in a very reliable way and identify those infants that present these differences and are at risk of developing ASD, we can try to modify and improve their neurodevelopment through early intervention. And we know that early intervention is very, very effective in improving developmental outcomes in children with ASD. We also need to remember that the brain is incredibly dynamic and is changing all the time, and development is programmed not just by genetics, it's also influenced by environment, and therefore the input the infants get. So the earlier we intervene, the better is for the outcomes of these children. How do we study early development in ASD if it's only diagnosed later on in life? Well, we need to have a population that we can follow from birth or shortly after. So at the bottom of the pyramid, it's represented the largest population that we can look at, we can study. So this is the general population. So these are the easiest children to study, but also on the other end, only 1% of these infants will receive an ASD diagnosis later on. But as we go up the pyramid, we end up with groups that are more rare, but they also have a high risk of developing ASD. Now, the group I really want to emphasize is the familial risk group. So far, this group has received the most attention and has mostly been studied. So these are infants that are at risk of developing ASD because they have an older sibling with ASD as well. So they present a genetic risk of developing the disorder, and around 15 to 20% of these infants will actually receive an ASD diagnosis later on. And promising findings have been found regarding this population. But now, how did the studies measure the brain in the first year of life? Well, this is where EEG comes in very handy. So essentially, we use these very fancy caps to measure the brain signals and to collect data from the brain. And then from the data, we can get a better understanding of how the brain is shaping and developing, both typically and atypically early in development. So all in all, I think we can agree about the importance of being able to measure early brain differences before an ASD diagnosis is made. Now, I will briefly discuss my PhD project. So going back to the previous slide, I mentioned that the familial risk group has received the most attention so far, and very promising findings have been found. Now, this is very important, and it really shaped the ASD field, and we now have a better understanding of how ASD is developing early on in life. Now, I also mentioned that ASD is a very heterogeneous disorder. So it's also important to also look at other subsets of high-risk infants to also get a better understanding of how ASD is developing. So this is where my project comes in. So I will be mainly focusing on this other high-risk group of infants. So these infants do not have a family history of ASD, but they present early red flags of the disorder. But of course, they're too young to actually receive an ASD diagnosis. So essentially, we aim to investigate if we can replicate previous findings from the familial risk studies, and if we do, it's of course of great importance also for the development of future intervention programs. So in the next slides, I will briefly show you what we aim to investigate and look at. So I've told you at the start of my presentation that children with ASD present differences in the social domain processing. So what I have here in the slides is just an example of this. So here I reported the findings from the high familial risk studies. So essentially here they found that infants that were at risk of developing ASD did not show interest to the face of an orchestra singing. So this was opposite to the neurotypical peers, which mainly pay attention to the eyes and the face of the actress. And so these findings have been reported many times in studies. And what we see is a decline to social information and specifically social features in children with ASD in the first few years of life compared to neurotypical infants and children. Now, these differences in social processing also can have huge impact on language. And in fact, delays in the acquisition of spoken language are one of the most commonly reported initial parental concerns that leads families to seek diagnosis of ASD for their children. Now, neurotypical infants are usually born with innate preference for speech, and they also particularly keen to listen to infant-directed speech. Now, infant-directed speech is just a fancy way of saying baby talk. So it's a very special way that parents shift or when talking to their babies. So this is very important because the process of listening to one's native language actually tunes the auditory perceptual system to better discriminate the sounds that it's hearing on a daily basis. So as we hear more language, we become essentially better able to perceive language. By contrast, children with ASD, they do not prefer to listen to speech or infant-directed speech for that matter. And so this can have a very negative effect on early language acquisition, as the auditory system might not specialize to the sounds of one's native language. And so our main aim is essentially to investigate the risk factors for language delays early on. And children with ASD also experience sensory challenges every day. So some children might not respond to their names or might be very sensitive to sounds. So these sensory challenges may contribute to also social difficulties, language delays, and repetitive behaviors. And the repetitive behaviors seen in ASD may originate in the striatum. So it's essentially a cluster of neurons which essentially is activated by rewards in social situations. And people with ASD have been shown to display unusual low activity in this part of the brain. And this might explain why some people with ASD seem to have very little interest in social interactions. And so our goal is to really investigate the impact of sensory differences on social and language processing. in our subset of infants. So I hope that hearing why my project was interesting for some of you. Now I would like to wrap up the presentation. So I've given you a lot of information, and I hope that I also excited you a bit about where the field of ASD is moving towards. But what I really want to emphasize here is the concept that the neurodevelopmental processes that underlie ASD start well before a typical behavior's emergence, certainly well before a diagnosis is made. And so we hope that with our work, we can contribute to the development of also future interventions, and we can also get a better understanding of how ASD is developing early on. And I would like to leave you with this quote by Neil Armstrong, which I think is very fitting for my research, and I think for research in general, and I hope it can inspire you as well. Thank you for listening.
Thank you very much, Kloe, for taking us onto this journey into the neuroscience of autism. And I really liked how you also explained what autism spectrum actually means. And I hope that our viewers also maybe learned a thing or two that they didn't know about autism beforehand. So our next speaker is Marlene. Hi, Marlene.
Hi, Lena.
Hi, how are you doing?
I'm good, thank you.
So you've been at the BRC for quite a long time, right?
It's true. I started more than 10 years ago, which is around 2008, when I did my master's studies. And then, yeah, I kind of came back to it after having a short interleave in Chicago. So it's always been a pleasure to work at the BRC.
Wow, that's cool that people also come back to the BRC. And in all those years, what is it that was most exciting for you about working with kids and young children?
Good question. I don't think that there's one single thing. It's really, for me, the unique combination that this studies allows you to do. So it's both working with wonderful families, but also to have really inspiring discussions with researchers of all different kind of fields. And at the same time, if you have seen children develop, especially when they're young and in the first, like, let's say 3 years of their life, then you, I guess, can't help but wonder what is happening and how they develop so fast. And it's really a pleasure and a fantastic thing to be able to help and contribute to unravel at least parts of this mystery of how the developing brain is emerging.
Okay, thank you very much, Marlene. And we will dive right into your presentation.
Hi, I'm Marlene Meyer, and I'm happy you tuned in today. I am fascinated by the way the little ones manage to navigate our complex social world. How do they learn to, for example, play successfully with others, to interact with others? What do they think about others? And how do they learn from others? That is exactly what I'm interested in my research. And in particular, I'm interested in how the baby's brains and their behavior are changing in the first years of life, especially given the way we sometimes act around them. You might recognize this in yourself, at least I sure do, that when I'm playing with the baby, I change the way I behave. You might call this peculiar, but interestingly, especially for the way we speak with our babies, that seems to draw their attention, as well as help them in language learning. But what about actions? Do we also change the way that we're moving? And why would we do that? That is something that we looked into in our recent study. And what we did was we invited parents and their babies to our lab to play with new toys that we had prepared for them. The new toys look a bit like this, and you might ask yourself, what can you even do with those? Well, it turns out they all have a different function. Some you can rattle, others you can twist, and yet others again would turn on a light if you push on them. So we gave parents and their child a chance to play with those toys. And we were curious in the moment that parents showed those new toys to their babies, how they would move. So we measured their movements in 3D space. And that's what you can see here. So let's first see how this mother is showing a new toy, a rattle in this case, to their baby. Here you might have seen in the green trace how the mother is moving when she's showing the new toy. Now let's compare this to when she's showing the same toy to me, an adult she thinks does not know how this toy works. Well, you might have already detected a difference. They're moving differently when they're showing their baby their toy. So for example, they repeat the action more often. They're moving bigger, larger, slower, sometimes smaller, and closer to their baby. Well, what is behind all of this? Because if you think about it, what we want babies to learn is that the rattle works like this, not like this. So why do we exaggerate? Well, we would love to ask the babies themselves, are you paying more attention to it? Or is it make you learn better? But then we could ask them, but we might not understand the answer. Luckily, we have nice techniques to help us measure their brain activity and find out what they're thinking. We could use, for instance, EEG or electroencephalography, a technique that is both safe and baby-friendly. Works a bit like this. It looks like a bit of a swimming cap, I guess, with sensors on them that can measure the tiny currents that are going on in their baby brains. Typically, for adults, we would ask them in an experiment to sit still, not blink, or not move for at least like 3 hours. Well, that wouldn't quite work with babies. Of course, they can't sit still for that long. We can't ask them not to blink or not to move for 3 hours. But as researchers, we're not inclined to give up that easily. With love, patience, and mostly with the goodwill of our little participants, we managed to do something that is astonishing, namely see the brain activity of the babies when they're watching a video that we're showing them. And what do we show them? Well, we were curious about, first of all, how do they react when we show them normal movements? So a person in this case putting rings on a peg. And then compare that with their brain activity to movements that are mostly just larger. So always like this. And then again, we would compare it to movements that are more varied, more diverse, something we also see in adults, that when they're acting towards their baby, that they're changing the way that they're moving, sometimes high, sometimes low, sometimes slow, and sometimes fast. What would they pay most attention to? In fact, what we see is that babies pay most attention to the varied, more diverse movements. And you can see that here, represented in the brain, sort of from a top view, that the frontal areas are more activated when babies seeing these varied, diverse movements than just normal or a lot of just bigger movements. So it seems something to be in the surprise of the movement that captures babies' attention. And in fact, we also see that it seems to help them in learning how to use the new toy when we later measured how they would themselves put rings on a peg. So all in all, what we saw was that parents not only change the way that they're moving when they're showing their baby a new toy, but also babies tend to pay more attention to those changes in movements, especially when they're diverse. And they might actually learn how to use the new rattle that they just got for their first birthday. Thank you very much. I hope you enjoyed it. And thanks a lot for all the families that participated in this research and made this all possible.
Hello everyone. So Lena was
Thank you, Marlene, very much for your presentation. I apologize for the technical difficulties. I've had several people let me know that the presentation was not full screen, but I kept getting an error message when I tried to make it full screen. But I hope that didn't distract anyone from Marlene's journey into large and small and varied movements. So last but not least, we have our final speaker, Nicole. Hello, Nicole.
Hello, Lena.
How are you doing today?
Yes, great. It's been a lovely day today.
Yes, I also really enjoyed the nice weather today, and I hope you were able to do that too. So how long have you been at the BRC, Nicole?
Actually, many people don't know that. I've already been at the BRC in 2014 for my bachelor thesis that I did in the baby brain group. And then I came back for the PhD at the beginning of the last year, so just before Corona started.
Okay, so another person who returned to the BRC after being away for a while. And what do you enjoy most about working with children?
Yeah, there is a lot. Like Marlene said, for first, it's just good fun to work with children. They are just so curious and open-minded. But also, it's in terms of a researcher, it's challenging, and in a good way, it makes you come up with these creative solutions how to study things that you could have so easily studied in adults. But there are so many questions we can answer as a researcher when we study babies. And I think the BRC is a good example for how many different methods there are to study babies.
Yes, I totally agree. I was very impressed when I started at the BRC, how many people come together and what different backgrounds they have, and they all bring their expertise and their methods to the BRC, which makes it quite the unique place to do infancy research. So to our viewers, sit back and relax for the last talk. After the last talk, I will share with you the link where you can vote for your favorite presentation. So let's give the stage to Nicole.
Hello everyone. So Lena was so kind to already introduce me, and she asked us to keep introductions of ourselves during the talk short. Lena, I will try. So let's start in the early 90s. I was born in a small tiny village in southern Germany. Just kidding. This picture actually shows the topic of my talk, which is contact-based interventions for infants. Or simply put, during my PhD, I want to find a scientific answer to the question, should we cuddle babies? While the answer might seem quite obvious, I want to show you why and how I studied this in 2 different projects. But let's start with a short quiz. What do you think is the largest organ of your body? The largest organ is actually the skin. The skin covers 2 square meters, and the sense touch is already developed in the mother's womb. In fact, newborn infants highly depend on caregiving touch throughout the first weeks of their lives. In Colombia, in a hospital, in the 80s, when incubators were overcrowded and the hospital didn't quite know where to put babies that were born too early and needed special care, they had to come up with a solution. And this was not a solution. In fact, they did a quite natural thing. They used this knowledge of touch and placed the babies wearing only a diaper on the mother's bare chest. And this was the invention of skin-to-skin contact. This procedure proved to be so effective that the babies were doing better than babies who were cared for in an incubator. They showed better temperature regulation, they were less ill, they cried less, and they showed less levels of the stress hormone cortisol. In fact, skin-to-skin contact is still used today and highly recommended by the World Health Organization because it is such a simple intervention. But what about babies that are not born too early or with any health issues? What about full-term babies? Well, less is studied about full-term babies and skin-to-skin contact, but we do know that full-term babies also highly depend on caregiving touch. And what is known is that skin-to-skin contact can improve also their temperature regulation, they cry less, and it also benefits the mothers who then have less stress symptoms and they have a better ability to breastfeed. So all in all, this procedure is part of the standard care in many hospitals around the globe in the hours after birth. But what happens after that? We know that the infant still depends on contact and closeness of the mother even throughout the first weeks of life. So it is suggested that skin-to-skin contact might also be beneficial on a daily basis. And this is what Kelly Koymans wanted to study when she set up the Skippy project. She had 2 scientific groups. She randomly put mothers into either a skin-to-skin contact group or a control group, and she asked mothers in the skin-to-skin contact group to perform 1 hour of skin-to-skin contact daily for the first 5 weeks of the infant's life, and mothers in the control group were not asked to perform anything in particular. And this allowed her to compare the 2 groups. Usually, when you compare 2 experimental groups in a study, you let the participants do the intervention, you have the control group who doesn't do the intervention, and then you compare the groups with some kind of questionnaire. But as you can imagine, this is quite tricky with our younger participants. So we had to come up with other solutions. Parents, for example, filled in questionnaires, or the infant took part in samples of physiological measures. And there was one particular physiological measure that we sampled that infants have quite in a large amount, and they don't mind to share it. Saliva. And Kelly sampled the saliva by swabbing the infant's mouth and letting the infant chew on a cotton swab. This allowed us to look at the reactivity of the stress hormone cortisol. Former studies have suggested that skin-to-skin contact might decrease infants' stress reaction to stressful situations. They found this in full-term and preterm infants. Also, the preterm infants, they showed cortisol levels that were more similar. They were synchronized with the cortisol levels of their mothers. The researchers suggest that this was the case because mothers and infants in the skin-to-skin contact group, they had more facial interactions. They exchanged more cues of touch and smell and also hearing. So they suggested that they develop a co-regulation. However, this has never been studied in full-term infants who haven't been born too early. So in this project, we wanted to first assess, does daily skin-to-skin contact decrease infants' and mothers' cortisol reactivity to a stressor? And can it increase synchrony between the 2? In week 5, mothers were visited at home and infants were exposed to a stressor. But this sounds scarier than it was. In fact, newborn infants already show mild distress when they are given a bath. So mothers were asked to bathe the infant, and saliva was swabbed before the bath, 25 minutes later, which is when you see the stress response in the saliva, and 40 minutes later to see how the infants recovered from the bath. And then we performed a multi-level growth curve model. This is a mouthful, and this sounds scarier than it was. In fact, it was a statistical test that allowed us to compare the 2 groups over time. This is what we found. Let me walk you through. Our first question was whether skin-to-skin contact can decrease infants' reaction to distress. You can see on the left side the control group, and you can see that before the bath, at time point 1, their cortisol levels were lowest, and then they increased as a response to the stressor, and they decreased when infants recovered at time point 3. And the same thing happened in the skin-to-skin contact group. Even though those lines might look slightly different, you can, in a statistical test, see that they were not statistically significant, which means that we did not find a difference between the 2 groups. The same was the case for the mothers. Even though the lines might look slightly different in the control group and the skin-to-skin contact group, there was no difference between mothers of the two groups. We did have a second question though. We also wanted to know, does daily skin-to-skin contact increase cortisol synchrony between the two? And when comparing the mothers and infants in the control group, you can see that mothers in the first, before the bath at first, showed the highest cortisol levels, while infants showed actually the lowest cortisol levels. The mothers slightly decreased in distress, while the infants showed a stress response and then a recovery. When looking at the right-hand plot, you can see that mothers in the skin-to-skin contact group slightly followed the infants in a stress response. And our results indicated that mothers in the skin-to-skin contact group tended to synchronize more with their infants. So we concluded that daily skin-to-skin contact does not decrease infants' and mothers' cortisol reactivity, but it might enhance the synchrony between the two. However, now I have only talked about behavior, and we don't actually know what has been going on. It is hard to judge this pattern of co-regulation, who synchronized with who. Maybe the mothers were more sensitive, and because of that they were better able to synchronize with their infants. So to see this, we are scoring the videos of the baths to see the sensitivity of the mother, but also the engagement of the infant and the infant's mood. And this is a work in progress. Another work in progress is the project that I'm currently planning, because we now know that infants highly depend on close contact. But what happens when mothers go back to work? When the infant is 3 months old, many infants in the Netherlands actually go to center-based care, where they receive slightly less contact than what they are used to from home. And this might be challenging. Accordingly, a former colleague, Esther Albers, has found that infants, when they start with center-based care, have higher cortisol levels on days at center care when compared to days at home. So this suggests that it might be challenging for the infants to get used to the new situation. So we want to see if we can support the infants in center-based care. This is already being done by buddies in hospitals around the globe, which are usually senior volunteers who visit the infants, hold them and give them some more contact. And we want to see if we can go to daycare and also support with trained buddies the infants, and therefore by holding the infants more also support the daycare employees. If this study should find positive effects for the infants, we can imagine that this might lay the groundwork for a larger project to see whether not only the infants but also the senior volunteers can benefit from this intervention. I'm sure my granny would. Thank you very much for listening.
Hello, everyone.
Okay, that was our last presentation. Thank you very much, Nicole, for telling us all about skin-to-skin contact and about cuddling babies. So we've seen 4 wonderful presentations today on very different topics, and all of the speakers approached this differently, but I personally think that you can see that everybody put a lot of effort into it. But we also want to crown the champion today. So we have prepared a little Google form. I will share the link with all of you now, and you can vote for your favorite presentation. So if you head to this link, tinyurl.com/BRC Science Slam, you will find a Google form where you can just click on the presentation that you like best, hit submit, and I will tell you a bit more about how to stay in touch with the BRC while you're voting. The URL where to vote will be visible throughout the next slide, so if you missed it now, don't worry, you can still see it and you can still vote while you listen to me talk. Thank you everyone who tuned in today. I really hope you liked it. And if this got you excited about the research that we do at the BRC, there are several ways to keep up to date with all of the stuff that we do here. So first of all, we have a website in English and in Dutch, babyandchild.nl. En voor de ouders uit Nijmegen die er vandaag naar een Science Slam kijken, ouders kunnen zich ook op de website aanmelden om deel te nemen aan ons onderzoek met hun kinderen. For those of you who don't speak Dutch, I just told parents that this is also where they can sign up for our studies, because of course, as early childhood researchers, we always depend on families who take part in our studies, and we are very thankful for all the families that are already part of our database, because without them, those presentations that you saw today would not have been possible. Other ways to stay in touch with us are through our social media channels. We are on Twitter, we are also on Instagram, and we are on Facebook. I would like to give a shout out to my colleague Josje here, who is managing our Dutch language channels and doing an amazing job at breaking down the science that we do and telling everyone who's interested, parents, other researchers, just people who like science, who like research, about what we do here. So thank you, Josje. And thank you again to everybody who presented today. To everyone who's watching, don't forget to vote. I have one more little thing to tell you. This is an announcement for all of the students and early career researchers who might have joined today, because if this Science Slam got you excited about the work at the BRC and about developmental science in general, we have just the thing for you. The Baby and Child Research Center is organizing not just one, but 2 online summer schools this week. So if you enjoyed this evening and you were like, oh, I want to know more about developmental science, but I also think that my couch is really, really comfy, check out our summer schools. They will be held fully online. You can attend either one course or both. More information can be found at ru.nl/Radboud Summer School, or just type Radboud Summer School into the search engine of your choice to learn more about the Radboud Summer School and all of the cool courses they offer. The Radboud Summer School is organized by the university and has a range of different courses, not just the 2 Baby and Child Research Center courses. So give them a visit, and maybe we will see you again this summer for our summer school course. Again, the votes are coming in. Thank you very much. But what will the winner actually get? Wow, okay, this is your last chance to vote. I will close voting in a second or 2 after I've presented this slide. So the winner of the first Baby and Child Research Center Science Slam will get a unique hoodie with the Baby and Child Research Center logo on it, which is the perfect apparel for working from home, of course, but also for taking a walk in the spring sun. Today was excellent weather to take out your Baby and Child Research Center hoodie and show it to the world. And of course, also attending online conferences where you can just represent the BRC in your glorious new hoodie. I know that all of our participants put a lot of time and effort into their talks, and I want to thank them for participating today and for taking the courage to go on stage here and talk about their research. So everybody who took part today will get this very fancy BRC tote bag, which is perfect for carrying home all of your groceries, all of your working from home needs. So I will close voting very soon. There's a slight delay between what I'm telling you now and when you can see it on the live stream. So let's just take a break of a minute or 2 here while I have a look at the results. And I'll be back in a minute with our winner. Wow, exciting. Okay, see you in a minute. Okay, here we go. Are you excited to see who the winner of our very first BRC Science Slam is? I already know, and I'm still excited because there was a bit of a surprise here. So let's see. We have a very, very close race, which just goes to show that we had 4 amazing presentations today. And as you can see here, we have 2 winners. We have a shared first place. And let's give it up for the winners of the very first BRC Science Slam, Nicole and Kloe. Well done. Both of you will get a BRC hoodie. I will get in touch with you to see how it can be delivered to you. And thank you so much, everyone, for tuning in today. We hope you learned something today. We hope you had fun. And we hope to see you again on our social media channels, to see you here at our labs with your children, to hear from you. And we wish you all a very nice rest of the weekend. And I think it's time for a round of applause for our winners and for all of our participants. Yay! Wow, great. Okay. Thank you again for joining us tonight. Stay safe and take care.